So once again, let me emphasize what we said just now. I said so long as the pressure on the accelerator remains within a certain limit, this wheel does not skid on the road, and corresponding to the frictional force, the static variety, which can go to a max value of Fs max, limiting friction, giving the maximum acceleration of the car in the forward direction. In case the car wheel skids with a huge pressure on the accelerator, corresponding to the friction becomes Fk, and the value of A also comes down slightly from the value to achieve with the value of Fs max here. So once we see the case of car speeding up, let's go to the case of car slowing down, again with the help of sliding friction. We did not mention rolling friction till now. Be careful about that. So let us draw the case of car slowing down, and we keep the figures side by side for easy comparison. So this is the car already in motion, and the driver wants to slow down the car by applying brakes. So when he applies the brakes, you see that the major difference is that the wheel now exerts force on the ground slightly forwards to the vertical direction, not like this was slightly backwards. But this time during the brake application, the wheel exerts force on the ground in this direction slightly forward at an angle to the downward vertical. So the ground responds back by giving a reaction force onto the wheel that's acting slightly backwards to the upward vertical. And you can again resolve in two components. The vertical components called normal forces acting on all the wheels together. They cancel out the force of gravity acting on the car. While this is more importantly the frictional force, as you can see. Compare these two figures. This is the case of slowing down, and you can see the frictional force is now acting on the car wheel in the backward direction, that is to the left in my figure, opposite to the motion of the car. That's important. So here we go to write down the frictional force applied by the ground onto the car wheel in all the spinning wheels. This is acting to the left to brake, to slow down the car. And once again, if the driver applies the brakes gently within a maximum limit, then the wheel does not skid onto the road and the friction becomes Fs. On the other hand, if the driver applies the brakes suddenly with a huge pressure, then you'll find the car wheel will skid onto the road, and correspondingly the friction will become not Fs, this will become Fk now. So once again I talk about two types of sliding friction. No mention of rolling friction so far. Even during the braking of the car, let me write the acceleration part also. You can see the arrow direction. Acceleration is actually negative in the direction to the right, so I just show it to be arrow to the left. It means the car retards, decelerates in the forward direction. And that retardation is also caused by the frictional force only, sliding friction. So in one figure, speeding up, statical kinetic friction giving the speed up of the car, providing the necessary force, driving force for that. And in slow down, it is the same statical kinetic frictional force that resists the motion of the car and slows it down gently. And once again, to emphasize, if there is no skidding between the wheel and the road, static friction that can go up to a value of Fs max, giving the maximum possible retardation. And if the pressure is even more on the brake, the wheel will skid onto the road and it will be Fk now, giving retardation that will be less than that could be achieved with Fs max. Understand these two figures by proper comparison. So far our discussion has remained confined to only statical kinetic friction. No mention of rolling friction till now. So what about rolling friction? Let me tell you here, rolling friction also is acting on these car wheels, and since rolling friction always opposes rolling, be it the case of speeding up or the case of slowing down, in both cases rolling friction acts to the left in my figure to oppose the motion of the car. I write it here, this is symbol for that is Fr. So I write Fr and you compare that with Fs or Fk, I can see that the arrows are very small in length compared to the values of Fs or Fk, which means that Fr is numerically much smaller than the sliding friction. But it always acts to the left in my figure to oppose the motion of the car, be it the case of speeding up or the case of slowing down Usually, we just ignore this presence of the rolling friction in problems of this type of a driven wheel because Fs or Fk is so much larger than Fr, we can safely ignore Fr without incurring any significant error. But don't forget, when we discussed earlier the case of free rolling, we said it is the rolling friction that slowly, gradually brings the rolling body at rest in the absence of any propulsive force.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.